Hello everybody and welcome to another session on Affieter. In this today's tutorial we are going to learn something a bit more exotic, that is how to use Jupyter Notebooks, which are Python by default, with JavaScript. So let's dive into it and see how it goes. In our last tutorial we learned about Mini Conda and Jupyter, and we learned how to install it on our machine. We really need those to be functional before jumping into this tutorial, so I really recommend you to watch that lesson and have your Mini Conda and Jupyter ready for action. Now, as we know already, Mini Conda is a minimal Python distribution which can be used to create different environments with different Python versions. And on top of Mini Conda we can run Jupyter, and it's a really nice UI tool for on-the-spot code evaluation and for sharing with other people. Today we are going to learn about Deno. This is a new open source runtime for JavaScript and TypeScript and has a lot of built-in features, and the most important thing of them all is that it has a native kernel for Jupyter with a bit of an SVG graphic support. What are we going to achieve today? First of all, we will need to have a JavaScript-powered Jupyter Notebook up and running and ready for action. We will also learn, and it's very important to know how to import NPM packages, since they are the basis of the NodeJS ecosystem. Furthermore, we will add support for machine learning with Tensorflow. Now, Tensorflow has a really nice JavaScript library which is really fast, powerful, and works also with graphic cards, so we can leverage CUDA in order to speed up the machine learning process. It's also nice to see how we can plot some sample chart by leveraging Deno's SVG support. I will also publish the code to the GitHub repository, and for sure we will learn something new today and really exotic in my opinion. Before jumping in, I would like to mention that although this tutorial is on the fly, I did a preparation in advance because this topic is also new for me, and I want to mention that I had to downgrade my environment Python version to Python 3.10. And then, as always, the code that we'll produce today is MIT licensed, meaning that you can reuse it in every project that you want to work on. It's important, like always, to learn and adapt on the spot, since we are developers and we are also humans, and we are the most adaptable species on the planet. And I will hope you will learn something really new from a passionate developer working in his own environment. I'm now here on a virtual machine which I created specifically for this purpose, because I installed Deno on my own main machine and I don't know how to uninstall it so that I can show you an installation from the scratch. And here we are. What I did today was to create the setup with the Mini Conda and Jupyter. So if I'm going to the terminal and if I'm going like in the documents, what I did was to create a script which will initialize the Mini Conda environment. So if I run this script, it will initialize the Mini Conda environment, and it practically looks very easily. And I use the bash command with a new specifying the RC file, which is from my main folder, and I'm going to hit this evaluation command, which will hook Conda to our bash system, so we can see the base environment right here. Now also the GitHub repository has been cloned in my GitHub here. Machine learning TensorFlow. I do have the basis TensorFlow, which is the Python notebook. Good. Now what I need to do before starting, of course I need to activate my environment. But what I did was to create, if I go to the history, I should be able to see that the fact that I created this environment specifically for this tutorial, because there is a package. Well, I got some error somewhere, and I had to downgrade to the Python 3.10. I don't remember exactly where. It was a bit of chaotic, but trust me on this, it should work just fine. Now what we have to do is to activate our environment. If we activate and we check Python version, we will see that we have Python 3.10. Okay, super cool. Now what we have to do is to run Jupyter Notebook to make sure that it's running correctly. Okay, let's see if it's opening up. Yep, we have the Jupyter Notebook running just fine, and this is our last tutorial. Okay, good. Now if we go to what is called Deno.org, I suppose. No, it's not this one. Deno project. The next generation JavaScript runtime. Yeah, this is the one. And here I'm on Linux, so I'm practically going to follow up their instructions on my Linux instructions, installation, and let's copy that code. I think I'm going to stop the Jupyter, and I'm going to paste this command. We don't have curl. Okay, we will install Suara, no problem. Okay, let's install Deno. Yes, I want Deno on the path. Okay, and okay, I think that's it. Do I have this command? Then I think I need to restart the shell. Okay, I'm going to start the shell again, and I should have Deno already. Yeah, Deno 2.0. This is the correct version. Cool. So right now, let's see what we need to do next. I think there was a command that you needed to run in order to install it for Jupyter, but I don't know exactly. I think I need to look it up on their website. Let's see if you search Jupyter. Strange. Yeah, Jupyter. Okay, so if we go to this path, okay, we have Deno Jupyter. Good, I think we need to go to the that folder, documents, GitHub, and I will initialize my environment, documents, init Conda. Then I will need to say Conda activate, and this is where I have the Jupyter in my path, okay? Because this is what they say, that you need to have it on the path. Okay, and Deno Jupyter. Yeah, I want to install the kernel. I'm going to run this command. Okay. That was fast. Okay, let's run the notebook. The notebook is running just fine, and at this point we need to check if we have the how to say, the kernel. Oh, look, we have the kernel, the Deno kernel right here. Let's use it. Select. Okay, I want to rename this like one setup Java with Deno. Going to rename this, and this one should be already JavaScript enabled. So if I say console .log hello from DenoJS. Oh yeah, it works. This is super nice. Okay, let's see if those imbricated strings, if the interpolated strings are working. Const name, and then we will print console.log hello name. Yeah, they work. That's really nice. So we have access to the JavaScript already. Let's try a simple addition to see if it works in our notebook. So if I say 1 plus 1 equals 3, this means we have access to a full JavaScript engine, which has of course some limitations which we'll discover along the path. Let's see what we can do with the notebook right now. So we can, let's say, import, let's add something like, make it markdown, and we can import NodeJS native modules. For instance, we can import the OS module from Node.js. If we say import OS from OS, we will see that it's not working because it expects a different kind of import. So in Deno we can prefix our imports with practically the location that we want to use, or the directive, let's say. So in this case, if we want to import a Node.js module, we say node and then a colon, and voila, we have the OS module imported in our Node notebook. Okay, let's see how we can test this. So we can say console log current directory is, and we can say something like os.home dir, exactly like we would do in Node.js. And we can also say console log, we will say, let's see what the current architecture of the system is right now. Current archi os.arch. Super cool. We have the OS output right here. Okay, besides that, what else can we do with Deno? So practically in this notebook we can also import npm modules. And again, we will have to import with a certain directive prefix right here. Okay, let's say we want to have the equivalent of a data frame, like in we will have in Python, right, with the pandas library. So we can say something like import PL from the npm package which provides this feature, which is called We have to prefix with npm, and our package is called NodeJS polars. Okay. Let's see. If we see a star here, this means that this instruction is still work in progress. Yeah, it has changed, so right now the package is imported in the PL directive. Let's see if we can just read this, let's say, JSON from a string. Okay, let's supply it with a JSON, and we can say something like name Okay, and we will add also another property, awesome, which has the value of true, and I think this is it. Wow, you see, we have a nice output, like a table inside our notebook. But what else can we do? We can do practically a lot of interesting things. For instance, we can display some markdown with the notebooks, the Deno's display directive. Let's add another markdown, so we can say display markdown. This is Deno specific, so this is not from Node.js, okay? And we can use the display function, which comes natively in the Deno library, and this display function takes something like the type, and it's going to be text markdown. Let's add a text, note JavaScript notebooks with Deno by Affiliator. Let's make it bold. Let's add an exclamation mark and also add a picture. Let's add a picture from my website. PNG. Okay. And this takes another parameter which is called let's add raw because this is a raw instruction, and we set it to true. Okay, I forgot to end the string, this one. Display is not defined. Oh yeah, this is because we need to import it first. Let's add a new cell above. We need to import it from the Deno directory. I thought it's natively imported, so but you need to import it manually. For display, this is another directory. We can also import library, JavaScript libraries directly from web. So this is going Deno land x display and module.ts. Okay, has been imported. Yeah, we have a markdown here, but we don't have the picture. I don't know. Is this picture? Yeah. I'm not sure. I don't know exactly what's happening. Yeah, you need to add an exclamation mark. Yeah, I forgot an exclamation mark to make it obvious that this is a link that we need to import. Cool. What else can we do with this Deno notebook? We can use fetch to load resources from the internet. Let's add a new section right here. We can say use fetch to download files from internet. Okay, so how can we use this thing? We can leverage the response. So fetch is a simple promise which will return a response, and we will use await, let's say fetch HTTPS. We will load something from a public CDN, and this can be found also in the documentation. npm. We will download a world atlas, which is like a tab separated value file. Okay, I didn't see any error, so let's move on. So from response we will get some data. We will get some data with await response dot text. Okay, and we will use this data. Let's first use a console log to see this data. We see a bunch of things right here. They are not structured as it seems. They are thrown into the display in the console log, and that's it. But it's actually a tab separated value file, like a CSV, and we can use practically this polars library which we imported right here. We will use it to parse this data into a data frame. So let's do this. We will say let df equals pl dot read CSV, and we will use the data, and don't forget to add the separator. So if it's a different separator than a comma, like in our case we have a tab, we will specify the tab as a separator, and let's see, df, and let's print the data frame. Oh, nice. Now we have something really nice. Look at it. We have it in a more structured way. Okay. And the beautiful thing with the data frame is that we can group. Let's say if we can do df that equals df dot group by, we can group by continent. Group by continent, and let's see if we can do some aggregation. We can use something like df aggregation, and we can use the columns. So let's try to see first what columns we can aggregate. Just let's have another look on the df. And let's do one thing. So we have this here, and we will move on to another cell. So let's do an aggregation. So we want to group by a continent, but can I scroll it? Can I scroll it horizontally? Oh, there's a lot of data in here. Population year, population estimate. Unfortunately, I cannot do an horizontal scroll. Where is, okay, continent. And let's try to do some aggregation to count the population of the, let's say, continent. The population estimate. So this is the column that we want to aggregate on, and let's see how it goes. So let's add here a comment, add an aggregation on the population. Okay. So let's see. So the data frame can be used something like df dot group by. Let's do it in one stance. Continent. Let's add a dot over here. And dot agg for the aggregation, and we will say something like pl.call. So we will aggregate based on the column which is pop_est, the population, and we will use the sum. So we will sum it up, and we will call the column with another name. We will rename it to be like population. Okay. Alias population. And then we will sort. We can also sort somehow by continent. Dot sort. We will sort it alphabetically, and we will also show the df. Very nice. So we can see the population of the continents, and they are right now, as you can see, ordered by the alphabetical name of the continent. Let's see if we can sort it by population. I don't know if it will work. If we'll say here population, will it work? I'm not sure. Group by failed. I think you cannot simply sort it right now by this, since this is an aggregated column. I suppose we can do the sort by population afterwards. Let's see, I don't know. Let's df.sort. Population. That's tricky. Maybe if we can sort it by very strange. Pop_est group by failed. But which one is crashing? The first one? But this is odd because it was working. Continent. Ah, yeah, we need to reinitialize the data frame. Oh gosh. Where is that? Yeah, we need to use another one here. Let's see, sorted. I don't know. Sorted df. Sorted df equals df dot, and let's make it sure that our df is like what we had originally. Yeah, we had the original data, that is okay. and let's try to sort by population. Okay, and let's print it out. We will print out the sorted df. All right. It seems that Asia has more population than Africa. And the 7 seas open ocean has only 140 people. Even Antarctica has more. Okay. I can't say if this data is true or not, but it's really working that fine. But how can we do a power sort in reverse? I think we have to use reverse true. I think this is the right parameter to use. Nope. It's not working this way. I think it's practically easier than that. So as we can see, this value says that it could not be converted to Boolean. This means that I supplied an object which could not be converted to Boolean, of course. But if I say just a Boolean value directly, I suppose it should work. All right, let's see. We can see that the population is now sorted correctly as we want, in the descending order. The next thing that I would like to do is to change this casing for the continent, because I want everything to be aligned and in good shape. Now we cannot use AGG because this is an aggregate method, but we can use the select method in order to achieve what we want. And we can use select at the end, and we can say pl.call. So practically we will select the continent column and we will rename it to continent with a capital letter. Continent. Okay, but what we can see is that the population has gone. This means that in the select statement, we will also need to add the population column. So we can use pl.call population. Marvelous. So we have this thing right now, very elegant. Yes, so moving forward from this part, we can also plot the data into a chart and visualize it correctly. First, let me add a markdown so we can track it down, and we can say something like use plot library to plot a chart. So we are going to use the data above to plot a nice chart with the plot library. This library is going to be imported something like import plot from HTTPS, and this is coming from Deno land, and it's called xplot mod.ts. I wouldn't say this is a very elegant way to import their libraries, but this is what they provide in their tutorials, and I don't know if they will change it or not in the future. Then we can use a variable to load the records. We will load the records into a tabular data. So right now we have them into a DataFrame format, which can be aggregated, sorted, and then we need, in order to use it in a plot library, we need to have it in a tabular format, and we can use the toRecords function. Let's see how we can do that. So we can use the sorted df, which is the data frame that we created before, this one that is shown here, and we have to leverage the function toRecords. Records sorted df toRecords. Let's see how these records look like for now. They should be exactly an array. It's simply an array of objects, of JavaScript objects. That's nothing more than that. Now let's see how we can use this plot. First of all, in order to start with the library, we will have to call the plot function. And it will require some parameters. Okay. And we will need to add the marks of the plot. And this is an array. And for now, I mean, we will only use the bar x, and we can say plot.bar x. This function requires some the records, the array of records. We have it above, and a bit of configuration. So we will essentially need inside this configuration to supply the column or the property name for the X column, which will be population, and for the Y column it will be the continent. Okay, we can also change the color. We will have, let's say, a purple. And I think it should be it for the moment. Let's see if it works. Let me delete this one so it doesn't entangle us. Okay, I forgot something. Got blah 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 blah. That's pretty ugly because I really don't have any idea where I've mistaken. Yes, I forgot to close these parentheses. Alright, so we have a chart, but it's a bit overlapped and I don't like the fact that it's not sorted. But still we have a chart which was created quite fast. So so first of all, I want the chart data and everything to be a bit moved to the left. So I need a little bit of margins, and I can use the margin left property, and I will add, let's say, 200 pixels. Okay, so I managed to move it to the left. Maybe it can also stay a little bit, let's say 180. No. Okay. Okay, I don't mind, but I don't like the fact that it's not sorted in any way. In order to sort it, although the records are sorted, but somehow the plotting mechanism takes them into the alphabetical order of the continent, we can supply a sort function or a configuration, whatever you want to call it. So we would like to sort the Y column based on the X column. This is how the configuration parameter looks like. Right now it's sorted, but I want it to be in reverse, so descending. And you can also specify reverse to be true. And yeah, we have everything ready. So we can notice that in Asia we have a 4 billion population. Then we have in Africa something like 1 billion. In Europe less than, yeah. And the others are so small they are not even rendered on the chart. And that's okay. I mean, we have a really nice chart in less than 5 minutes, I suppose. So this is really powerful, especially if you are, let's say, not into Python, or if you want more of a JavaScript approach on the thing. We are approaching a final step in our tutorial today, and it's about time to learn how to import Tensorflow JS in order to activate the access to our next tutorials and be able to use machine learning in our projects. So let's add a new section here. Import TensorFlow JS libraries for ML projects. Okay. In order to do so, we have to use the import statement, and we will use import tf from. We are going to use npm directives if we have TensorFlow already available on npm directory. TensorFlow, and it's going to be TFJS node core, I think. Oh no, it's CPU. Let's try the CPU version. No? Then it's going to be core, I suppose. Let's wait for the process to finish. Okay, we have TensorFlow for JavaScript. Alright, let's see if we can use it in one short, easy to use and easy to understand machine learning project. Let's create a new model. Our model will be a sequential model. Let's see if we have access to this. Nope, we don't have access to this because I think we need to use Node. Let's wait for it to be imported. The idea is that we have some library for the CPU and we have another library for the GPU. Exactly what I was thinking. So the problem is that somehow the Deno framework cannot build this native, let's say, dependency. And that's why we get this error. It says that we cannot find this binding, TFJS for the node. Now, I didn't find any particular solution on this over the internet. However, I managed to accomplish to solve this issue by doing some kind of a workaround. But now I'm in this virtual machine and I don't think I have the node. Okay, I need to install NodeJS. And I will show you how to overcome that particular error. Let's wait for the Node.js to finish. Okay, now we have npm version. No, we don't have npm. I thought that the package will come up with the node with the npm. Okay, because I will need npm. Come on. Okay, I have a problem with the machine. Alright, back in business. It seems that I had an issue with the virtual machine. It seems that on Linux VMware is not so stable, so I had problems before and I don't know what to say. I hope it's not going to freeze again. What's this? No. Okay. First of all, I want to make sure that npm, this is where I was at the last step, is on the machine. And I want to install it. Let's install it. Okay. Another problem would be that maybe I don't have enough space on the machine since... Oh. I hope I will manage to pull this through and somehow extend the space. Okie dokie, let's see. Do we have npm? It seems we do. Perfect. Now what I would like to do, let's say I want to go to documents and I want to create let's say a sample folder. Sample NodeJS, and I will say npm init. It doesn't really matter what I add here. I just need a repository. Maybe I don't even need this one. Yes, it's correct. The idea is that I want to install that particular library which was crashing in our repository, and I will say npm install tensorflow TFJS node. I think this is this was the right one. Okay, let's see if it's installed correctly. Gosh, I have an error. No space left on the device. Yeah, the idea was to I wanted to install this and get that particular binding and copy it inside the directory. I will do another thing. Just be right back. Before going into the fix, let's first explain the issue a little bit. So if we go to the .cache folder, we should be able to see here Deno, and if we go to registries, I suppose, no, npm, and we need to find here TensorFlow. Good, and if we go to the node folder, yeah, for that 1.0, yeah, at some point they it misses some files inside. But where is the I think I have to look over the error again because I don't really remember. So I need to go into GitHub machine learning. I will have to initialize the Conda again. Okay, and all right, let's go to our notebook and try to see the error. So TensorFlow node, it seems it misses this part, this file. So if we go here, it's in the lib folder. No? TFJS node for lib. It misses that file, so we can create the folder structure NaPv8. And it needs this this particular file. But I will take this particular file from my machine, from the other machine, the main machine, not the virtual machine. Yes, I'm now navigating to the file on my main machine, and I'm going to copy it into the virtual machine. And let's see if we can import TensorFlow right now. we don't have the lib TensorFlow 2. I think we need to install something else as well. Well, for this one, I think we need to install the TensorFlow, the Python version. So let's do one thing. Let's do the same with the initialization. Documents, init Conda. Also in this Conda, activate. And we have to say pip install TensorFlow. Oh, but I hope we will have enough space. Oh my gosh, there are so many things. Now I'm back after installing the TensorFlow with pip. I'm not sure if this is going to solve the problem. Anyway, I remained without space. I had to increase the space available on the machine meanwhile, and I'm yeah, practically curious if it's going to work or not. I don't think it will, because I suppose we need some other library from somewhere else, or maybe this this thing didn't really take into the consideration the new library installation. I will have to restart this. Okay, I'm going to run this again. And I don't see any error. TF sequential. Let's see if this one runs correctly. Come on, come on. I hope I got this right. You know, whoever says programming is easy or it takes not that much time, if they say something which is, I don't know, takes 2 days and you can do it in 2 hours, they are totally wrong. In my opinion, they are totally wrong. Why does it stay so much? Model is not defined. I hope it's not an issue. I hope it will work. Come on. TF is not defined. Come on. Oh, again, the same error. Then something else is going on here. Now, I think what's happening, you remember last time that we added some interesting dependencies inside the cache of the Deno, right? Cache Deno, and we went to npm, and we went to TensorFlow, and we were like right here. And we added, I think, this binding, no, not this binding, in the library, we added this file. Okay, but it seems that it not only depends, it depends on more than just that file. So I will copy, or if you are on your own machine, because I was trying to do it before, but I didn't manage. No, just a second. Sample Node.js. You remember I wanted to do it before npm e, and it was like TensorFlow and ideally this will compile the native's bindings and we can take them from npm and move them to Deno. That's the only option in order to solve these issues. So I'm going to wait for this installation to finish. Alright, this one has finished. And let's see if we go into that folder, because we have sample Node.js, we have node modules, and we should have TensorFlow right here. And if we go to the node folder, we should be able to see in the lib, I think, yeah, we see this binding. And then at some point, I think in dist, there should be that problematic, look, this is the TensorFlow, which the Deno requires, but it doesn't have. So if we go to the Deno, and if we go up in the dist, right? Oh no, dependencies, deps. There's no folder with the dependencies, so we should be just able to copy them here, and perhaps we will manage to make it work. Let's see. Come on, it should be there. Come on. Binding deps. So deps. They should be here. So this guy doesn't want to see them. Well, I guess Jupyter needs a restart again. So I'm going to take it down and start it again. All right, let's refresh the notebook. I'm going to scroll down and okay, did it run? I saw something here is optimized. I suppose it should be okay. Yeah, I think right now it's okay. Yeah, whew. Finally I made it work. Yeah, it was tough. It was really tough. But this is how it goes in programming. You have lots of challenges along the way. Now, in order to continue, I promised the fact that we can try to fit a model into prediction to predict something. Let's do something like a model which predicts. Let's have another markdown here, and we will say something like we create a model which predicts the let's say the horsepower to kilowatts function, the horsepower to kilowatts function. This one is super easy and we should be able to pull it in no time. Good, so what is this fuss all about? So what is the horsepower to kilowatts? Practically, it's a function which converts a car's horsepower, which we all know what it is, to the kilowatts. And there is a formula for that. If we go to this website, they will tell us that the formula for 1 horsepower is to multiply it by 0.7457. So 1 horsepower equals 0.7457 kilowatts. Now our model which we'll create here will not be aware of this formula. We will just supply it to with some values and it will predict the appropriate results to a new set of data which we will put it to do. Okay. Now, in order to speed up the things a little bit, I had the sample ready in my here, and we will I will copy some code from my sample. Practically, I'm initializing the model, and I'm also adding the test data, the train data actually. Okay. So practically we are defining 2 arrays. The first array will be the values in horsepower. We see we have 5 values, and the second array will be the values in kilowatts. and each value, every index will correspond to the equivalent in kilowatts for the supplied horsepower value. So for instance here 2 horsepower will equal 149 kilowatts. Okay, good. Next we need to train the model. Let's train the model. We train the model by calling the fit method. We supply the arguments, the two vectors. We will specify 3250 epochs, which will take some time maybe, but it will make sure that the prediction will be correct. And validation split, so practically 30%, yeah, represented here by 0.3, 30% of these values will be for testing purposes. And let's see, we will then predict the data. First let's train, and then in the other cell we will predict the data. The model will be trained, is going to be trained right now. And then we will also add the cell, the next cell, with, oh, I don't like this output. I don't know why it created this output, but anyway. It seems the model is trained, and let's run the thing. Oh yeah. Practically I tried to predict the the kilowatt equivalent of these values. Also -12. Okay. Let's test it out with our converter. So 200 horsepower equals to 149. As you can see, the model predicted 149.13 and the actual value is 14, which is very, very good. Then what's the next value? We have 10,000. 10,000 equals 7 kilowatts. I don't think so. Ah, 7 kilowatts. No? Or 10,000 horsepower. I think something is strange. 14. What's happening here? Okay, my machine, I think it crashed again. But the idea is very, very simple. So we can check that these values are really, really correct. Alright, coming back after my machine was frozen by the virtual machine drivers or whatever. And I think in the future, if I'm to use a virtual machine, I will switch to VirtualBox. Maybe it has a better support for Linux, because it really caused me a lot of problems today. And making this video really took a toll on me. So for now, I managed to recover the notebook, and I kind of managed to add the prediction and also the fit and the training and everything, and they work. So practically, if you verify these values with horsepower to kilowatts calculator, I did it before, and they will kind of be very, very close. And it's really interesting, since we didn't supply the formula to the machine learning algorithm in any way. So it was able to detect the relationships between the numbers very, very closely. Okay. And before wrapping up, in order to, if you have a CUDA, I added this note here, if you have a CUDA on your machine, use this import with the CUDA. Sorry, this will be CUDA. No, not CUDA, sorry, GPU. I'm really exhausted as of now. Okay, you can ignore this things and you can move on. And with the GPU, the fitting of the model should be a bit faster, but it might not make a big difference in our case because this is a very easy prediction that we do today. And for the future, yes, I tried this canvas with the D3 library these days and it's not working, so there is certainly a problem over there and I didn't manage to pull it through, but I don't think it's really important for the tutorials that I plan to do, and I have this Jupyter with JavaScript notebook ready for those, and they will be really interesting. Now, I want to thank you all for having the patience of watching this video. If you are really more curious about what I do, you can jump into my website aviator.com. And I also have the blog with all the articles that I write in my blog on afivan.com. Any feedback, any comment is greatly appreciated, and I hope you enjoyed the video today. Have a nice one and all the best. Cheers!